morning, good evening, good afternoon. Hello, wherever you are, and welcome to our interview Kickstart series on career conversations. I think, Christian, you can probably kick us off with an introduction since you are the guest of honor today.
Sure, happy to. So my name is Christian Monson. I have a background in computer science and then did a PhD at Carnegie Mellon University in computational linguistics. Then I worked in industry for about 9 years. I was at Amazon for 5 years. I worked on the Alexa personal assistant. I joined just before it came out, and then for the first 5 years of Alexa, I was there. After then, I worked at smaller companies, well, also before I was at Amazon in the speech recognition space. And for the past 5 years or so, I have been a independent tutor and mentor in AI and machine learning, computer science. So among my own private students, I also teach here at Interview Kickstart and do mock interviews, that kind of thing.
That's all good. I'm Snigdha. I currently work as a principal AI analyst at HubSpot, and what that mainly involves is it's kind of the bridge between business and engineering and understanding the changing business needs and then working with engineering to like build solutions in the AI space. And so, as you
Oh,
may have noticed, currently the trend is towards LLMs, so that's what we've been working with a lot. Before that, I
yeah.
was an ML engineering manager for a small startup called Swayable, and we focused on creative content testing using machine learning and AI to determine how persuasive ads were.
Uh-huh.
And so, an example of that was we worked a lot with the Democratic Party of the US as one of our major clients, and we would test their ads to make sure that they were persuasive and that people were who were watching them would vote for the candidate featured in the ad. And then before that, I was lead data scientist at North America's largest ed tech company, which is Smart
Uh-huh.
Technologies. And so that's the smart boards in classrooms, if you guys are familiar with those. Yeah, and my background is actually in bioengineering, so completely different
Mhm.
field. And I did image processing, which is kind of how I got into AI and ML to start out with. So it's been
I see.
kind of a different journey. And I know that you mentioned having worked on a PhD in computational linguistics. You'll
Yeah.
also probably agree that the field has evolved a lot just in the past 10 years.
It is radically different. So I got a PhD in natural language processing, but everything that I did is now irrelevant. Essentially, my PhD was more a symbolic machine learning approach to understanding language structure, particularly the morphology or the conjugation structure of a language. And now an LLM could just do that by itself. So you don't need such specialized NLP anymore. Everything has just become the LLM. So very different world.
It's really
Uh,
crazy to think about. Also, really exciting because in who knows, in another 10 years, maybe we'll have a bunch of careers that we just did not think about.
Absolutely. I totally agree that, yeah, and everything will be different in 10 years. This field changes very fast. So there will be new things to do in machine learning and AI and ways to use these new amazing tools. And that's how I think of these LLMs. They, don't usually completely replace old jobs, but more like extend what one human can do. So I found that a lot of people rely or trust too much in an LLM. Um, Kind of like people also trust too much in the web, even still today. If something is written down, people think it's true. Just yesterday, I was helping someone, and I guess it wasn't an LLM. Well, she Googled precision and recall for information retrieval. And it was an AI blurb that popped up. And at first I thought it was an LLM, but it turned out that it was more or less a quote from a web page that sort of misleadingly described what precision was. Said it was the accuracy of what was returned as truth, which is correct, but uses the word accuracy. And so usually machine learning people are very careful to distinguish. Accuracy is very different from precision. Anyway, and she was very confused by this returned result. And I told her that she was right to be confused because you cannot trust the web and you cannot trust LLMs. They are a good starting point. They get you moving in the right direction, but then the skill will be to know when an LLM or when the web is wrong and when the knowledge that you have is more than what the LLM produces. So LLMs are tools to be integrated in any job.
Okay, that's an amazing example. I have a bunch of follow-up questions, so I'm having a hard time
Great.
narrowing it down to just one. But so I guess specifically when you talk about the LLM, and this is also a problem that you mentioned, has just been like prevalent since the dawn of the internet. And even before that, even before in the before time when you would need to go to the library or like ask someone a question, the big issue is just accuracy of the facts and the statement. And like with our current situation, probabilistic models are by definition a little bit of a black box. So for you personally, what is an approach that you use just to make your models accurate, specifically with regards to training? And are there any tips and tricks or anything that you can share kind of along those lines to make the LLMs, to make other AI models more useful in that regard and less prone to hallucination?
That is an excellent question. So day to day, I don't build so many LLMs. I understand the problems with LLMs that there are hallucinations, and I don't have great tips and tricks for all you listeners out there for how to make LLMs better. I wish I did. People want those tips and tricks, and it, it's a bit of an art. And I also think LLMs are not quite there yet. I don't know if there are perfect tricks that can convince an LLM not to hallucinate, not to just make stuff up. You can tell it to do so, just in the prompt, tell it to not make things up, to make sure that everything it says is a verified truth. And anecdotally, I have heard that is helpful, but it's not a panacea. And in the end, uh, LLMs should not be used to make life decisions. They make mistakes and they will make mistakes and they're easy to mislead. Another fun anecdote, I meet with an AI enthusiast. He has a newsletter as well. He's a doctor, a practicing physician, and he had a patient that was on an all protein diet of the patient's own choice. The patient wanted to do this all protein diet. And my doctor friend was concerned and did some blood work, and there was some level that was completely out of whack. I don't remember what it was. Maybe it was sodium level or potassium or something that was very strange and not within the normal range. And the doctor said, you should consider going off of this diet. This is maybe not a great idea. And so the patient went to ChatGPT or his LLM of choice and typed in, isn't it true that you should expect high potassium when you are on an all protein diet? And the LLM came back and said, yes, it's very normal to whatever, and completely corroborated the patient's point of view. But that's what LLMs do. If you ask a leading question like that, it will answer whatever it thinks will make you happy. And yeah, so you should not trust LLMs with life decisions, financial, legal, health. You should do research and find real facts.
Yeah, that makes sense. I think even on the legal front, there's like the Air Canada debacle that happened recently with the chatbot on their website saying that the person could
Yes,
transfer their ticket for free. So
that's right. And the AI promised a free ticket or whatever because she was going for traveling for a funeral or some family emergency or something. And yeah, even, yep. And then they were on the hook for that. Yeah, LLMs
yeah,
have problems.
100%. I totally agree that they're not ready. Like personally, when I work with them, the best performance I found is like with RAG, which isn't really a true LLM, but it does give you, the user, more fine-grained control over like what you're actually surfacing to users and decreases the surface area for probabilistic generation.
Uh-huh. That makes a lot of sense. I've thought of RAG as more that you have a corpus of documents and you go out and you search those documents for relevant pieces, and then you include those relevant documents or relevant pieces of information into the prompt itself. And and then that helps guide the LLM, gives more background in the prompt. Is that basically how you
Yeah, that's
envision?
right. Yeah, you just incorporate the little bits of the prompt, the little bits of your document into the prompt, and you can make sure that you only include information from that document and not from the actual training set of the LLM by prompting it. So it's a little
I see.
bit better
Also, including in the prompt, you have to use this information from the
just letting an LLM run on its own. The best is if you have your own training set, but that's really expensive.
right. Yeah, to fine tune with your own training
Yeah.
set to guide it so that hopefully it will stick to your domain or your problem of interest. Yeah, cool.
Yeah. Makes sense. I think that based on that, I kind of want to specifically talk about like another thing that came up as we were talking about like the advancements in the field and talking about like how AI is not necessarily fully ready for
Uh-huh.
prime time yet, even though it's being used. And that is, can you talk about a little bit more about like job automation and the trends that you've seen there and kind of where you think we'll go in terms of whether we'll see jobs fully automated or if we'll see like a new job field or new fields as a result of AI and the advancements that we've seen just over the past couple of years, really.
Sure. So there may be new kinds of jobs, like people say that prompt engineer is a new job. I see it more as, well, even your position, what you're doing didn't exist 5 years ago. So there will definitely be people who get very good at prompting LLMs, building RAG systems, fine-tuning models. So these are all tasks that need to be done. So that will be one kind of new job that will happen. They're the AI specialists. And I suppose that it's not so much this is a new job, it's that there used to be AI specialists as well, and what they do has changed because the technology has changed. On the other hand, will LLMs automate other kinds of jobs, not AI specialists? So I am not a marketing person. I don't know marketing. And when I was initially thinking, what would an LLM be good at? I thought, marketing. It just makes up stuff. It sounds good. It's great at marketing. Then I was talking to a marketing person. I think he had some marketing background. Marketing wasn't his full-time job, but he'd done some marketing in the past. And he said that when he was using an LLM, I forget which, that it was a great first step, that you'd give it some background and have the LLM come up with some copy or like a Google Ads phrases, and it would come up with some good starting points. But from his knowledge of marketing, it was not enough. It wasn't perfect, and he had to tweak it more. When I ask an LLM to write a piece of code for me, it often gets partway there. Or if it's an easy thing to program or a common algorithm that is all over the internet, make a web page or build a basic feed-forward neural network, it can do that. But as soon as I ask it anything difficult, any kind of tricky algorithm that is not on leet code, it, it basically fails. And it often fails subtly, that it looks like it's right, it produces code, the code would run, and then you step through the code, and the code isn't quite there. I feel that LLMs will have this kind of behavior for a while. And probably they will get better and better, incrementally better and better, but they will always fail. And it will be the human's job to be the expert, to be able to read the code output of an AI or the marketing copy that an AI writes and improve it, make it so that it's actually ready for public use or actually implements the algorithm that the user wants to have happen. So LLMs are a powerful tool, and there's also a trade-off between you ask an LLM to do something, it produces code, writes an email for you, and then the question, is it faster to take that code or email, text, and proofread it and rewrite it? Or is it faster to start from scratch and write your own code or write your own email? And I think the answer will be different for different people. For me, for coding, anyway, LLMs aren't there. I grew up with coding and know all the idioms already, how to write code quickly that is efficient and organized well. And it's not worth it to me to try to debug the code that an LLM produces. On the other hand, people are now growing up with these AI tools, and they may well learn to use them so efficiently that it's more productive to collaborate with the LLM. And as the LLM gets better and better, I expect collaborative tools like this will that will be the norm. Everyone will just use AI and anything, writing an English paper or writing an email to your boss or writing a piece of code, and an LLM will just be a super word processor.
That's a really interesting view on it. I hadn't thought of it from kind of the marketing perspective, just having a background in engineering myself and noticing a lot of the things that you've been saying, like things that are incomplete, especially when it comes to things like SQL. I find that if you try and do something even slightly complex with a window function, even if you have no SQL background, it immediately becomes clear because you see key phrases just missing or incorrect. Um,
An LLM produces.
yeah, exactly. And just knowing that's true, especially in like more creative fields, gives you a really interesting view on like where jobs will be because maybe it isn't that we're going to completely automate and we're going to completely get rid of all the humans. It's going to be we need to be able to have humans who are good enough at their job to understand where the LLMs go wrong and really work like hand in hand with engineering to train them and to make sure that the tasks that LLMs can do are at least done well and to a caliber where you don't need to go back in and refine what you're doing.
Right. Yeah, and it's also true that so for code has to work the way it's supposed to work. Marketing has to actually attract people. But there are use cases that it might not be so important that things be worded exactly perfectly. Sometimes internal emails within a company, uh, they don't have to be perfect. The important thing is to get things done fast, to write it as quickly as possible, make sure the basic message is clear, but it doesn't have to be a masterpiece of English writing. So maybe that is a time when an LLM might be more useful. My problem is that I'm a perfectionist. So whenever I write an email, no matter how small to whomever, it always has to be perfect. So I personally still am not happy with LLMs, but there are people that are more about get it done, and an LLM can definitely be helpful there.
That makes sense. Yeah. I think if you're a perfectionist, there's never going to be an LLM or an automation solution that's going to be perfect.
I mean, someone else writes your email and you're still not happy with it, even though it was a human written. So,
Very true. No
right,
perfect executive assistant.
right.
Uh, I think that kind of brings me to my next question, which is like, other than just the accuracy of the LLM itself, what are other technical challenges that you've faced in projects that you've worked on in the past, maybe like at Amazon
Mhm.
or other places that you've worked that not just like with LLMs, but just more broadly in AI in general? And how have those problems changed throughout the course of your career?
I think a large part of my career and the focus and technical challenges that I've faced have had to do with data. the training data for a system. And I think this is still true in LLMs, although I don't train LLMs every day for my current position. The data that these LLMs need to be trained on needs to be high quality, uh, good in the right domain, on the right topic. Otherwise, they end up hallucinating and making things up. So at Amazon, I worked on Alexa, and had been working on a subpart of Alexa, building some certain models. And I had, about the time that I was preparing to leave, I thought that I had made some good progress. I was, I had some exciting results that seemed to be promising, trying a new type of model, a new way to train Alexa. And about this same time, a colleague of mine did a deeper dive into the data, and he found that the data that we had been using to train with was poorly labeled. That we thought we had humans that were doing a fairly good job of labeling the sentence classifications and the named entities, but when he looked more closely at it, it was pretty bad. And when he corrected it, all of my supposed results evaporated.
No,
It was a very depressing
no.
ending to my time at Amazon. Um, from after Amazon, I worked at a small company called Defined Crowd, and there I didn't directly build machine learning models, but instead I led a team that built a tool to clean and curate and prepare data for speech recognition. So speech recognition is going from sound into text. And so the training data needs to be paired written text and the words that were actually spoken. And you might think that text that you find on the web is those are the words that you say, but actually there's a lot of important corner cases that where spoken words differ from written words. So anytime there's numbers, so times or dates, you say 12:15, but it's written 12:15 p.m. or something. So it's what you actually say and what is written is often different. And so we were building a tool that could standardize, well, it would take written text as normally written uh, by a human following the conventions of a language and convert it automatically into the words that would be expected to be spoken. And yeah, I left before that project was completely finished, but there I left on a good note. It was in a good place. We had a good system put together, and importantly, Defined Crowd worked on not just English, but many different languages. So we had built a tool that was extensible to any language. You simply wrote down the rules in a sort of finite automata syntax that would convert from written form to spoken form. So data preparation, data cleaning, machine learning, work as a machine learning engineer, especially if you're on the more science side, like I am and have been, 80% data preparation, data cleaning, data verification, working with labeling people. Yeah, machine learning is all about data. Maybe that won't be true in 10, 20 years as much, but right now, these large language models, as much as any other kind of machine learning algorithm, are extremely data hungry. They just want as much data as you can feed into them. And which is not how a human learns language. We do not read the entire Wikipedia before we are able to speak anything. So there must be algorithms out there that are more efficient with data than what we currently have. And if we could find them, then it would be vastly easier to train an AI on a particular topic. We wouldn't need to have billions of tokens. We could just have the small amount of training data that we actually have right now and train a good AI that's a domain expert on uh, whatever it is that we care about.
That makes sense. It's almost like you're saying at this present moment, more than just generating the algorithm and having like a scientist talk about the algorithm, as a really strong data engineer or data preparer or like data labeler. So at the beginning of that pipeline is almost like worth their weight in gold more than the end result of the algorithm, because it seems like the complex algorithm with Alexa, if it had better data,
Yeah,
the result would have just been of like not having a viable model would have just been reached earlier. And maybe you could have made a simpler model or like a different model that had more use for a purpose.
absolutely. Yeah, I agree. I mean, the fun and exciting part of machine learning is often the algorithms. And learning those algorithms is fun. That's what brought me first to machine learning. But on a day-to-day basis, most of the time you use algorithms that already exist. And you do need to know how they work to some extent so that you are efficient with them and know their limitations and what to expect out of them. But most of the time you are not improving and modifying those algorithms directly yourself. You are a user of those tools. And since they are tools, they're usually fairly short commands to just run. And then it runs and trains on your data. And the computer does its thing. But you had to prepare all that data to get it into the right format, to get it into the right place so that algorithm could then consume the data in the right way.
Exactly. And I think that one of the most underrated parts of machine learning is just having really good grad students to help you label, like just the best available. Working at Swayable, especially on elections, we found that the best labelers were like actually political science grad students. And like, I totally get what you're saying. Like, we use the tools that were available to us. They really made the algorithms work and had their
Yeah.
elbows in the grease, so to speak, and kind of shaped all the data that we needed.
And they were domain experts too, that they were interested in politics and political science. They knew the domain, so they could label well. And in fact, that was part of the problem at Amazon with the story about Alexa. The data was low quality. The problem was that we had non-experts labeling the data. And we thought it was an easy enough task that they could do it reliably, but it turned out not. And yeah, it was a problem.
Yeah, that makes sense. And you often don't know until you're much, much further in the process because we're not experts either of all the labeled data.
Right. That is also true. We are experts at the AI part, not experts at whatever domain it is we're happen to be working on at the time. Yeah.
Percent. Actually, that kind of leads me to my next question. So, when we zoom out and we think about how this technology is being used and like where AI is, we see it in a lot of different domains and we see it in a lot of different places. Are there any trends just kind of at that macro level that are domain agnostic that really excite you and that you and your students may take an interest in?
So, like, what are the new directions that AI is going in?
Yeah, exactly. Just overall, any type of model, any type of domain and use case.
Yeah, so LLMs are amazing. We have been talking about them, that they are the elephant in the room, and rightly so. They are just amazing. When I was in grad school or at Amazon, the language models that we had, Ngram language models, couldn't even really write a coherent sentence. They would write coherent phrases, but then the phrases would get stuck next to each other, and from the beginning of the sentence to the end of the sentence, it was talking about something else. And an LLM now can write paragraphs of text that mostly hang together and make mostly sense. It might not have perfect logical reasoning if you look closely, or it might meander a little bit, but they are amazing tools. And it is in some ways, I did not predict that LLMs would come as far as they did. They blew me out of the water. And so I'm hesitant now to predict what's going to happen with LLMs, even though natural language processing is supposed to be my domain of expertise. I don't know. Are they just going to keep getting better and better, or are they going to hit a plateau? The last time I looked at the GPT papers, it didn't look like they were hitting a wall yet. Their extrapolations of what GPT, whichever, I think it was GPT-3 when I was looking more closely, that they had extrapolated from smaller models how good GPT-3 would be, and their predictions were pretty much spot on, and their predictions kept going up. So, and now, a year after GPT-3, models are better. The high-end models are even better at answering questions. And so maybe it will just keep getting bigger and bigger. However, these bigger and bigger models, they are starting to cost a lot of money. So one definite trend that I have seen is ways to similar performance as these high-end models, but using much smaller models or fewer parameters or less compute or more efficient chips that can uh, do these same calculations, but using much less power, energy, and money. So I think there's going to be a continual tension where the models will get better unless they plateau at some point. The models will keep getting better until it's too expensive, and then we'll have to find ways to rein in the cost, and then they'll get better again and rein in the cost, and it will keep happening in a cycle. And as these models get better and better, the number of different possible applications is quite amazing and perhaps not even known yet. I don't actively work in the area, but agents that use multiple LLMs to each focus on one particular task and then coordinate together to try to accomplish a bigger goal. I think that's exciting. And yeah, it's just moving forward.
Yeah, I think like in fields that are slightly adjacent, like with the generative image models, I know 10 years ago in image processing, back when I worked at the University of Washington in the medical department, our state-of-the-art research was basically just segmenting brain tissues. Like we were just able to get the computer to tell us like what part of the brain a certain image was from an MRI. And like
Mhm.
that was super exciting back then. And now if you just type in like MRI, you can generate your own MRI with like almost perfectly constructed. I mean, the details are vague, but you get the
Uh,
general structures. And so, like you said, it's just amazing to see how far that technology has come in such a short time and how we're doing things that we just couldn't imagine and how like innovation is still happening, whether it's like at cost reduction or like you said, like making smaller models and making a bunch of different, I guess you would call them ensemble, but that's not even really correct anymore because ensemble is more of like a classics ML system, but just that type of work. So I'm really excited to see where the field goes as well. I have one last
Definitely.
question. One
Sure.
last question, if that's okay. And that kind of plays off with the development of the field. So, with your students and with your business, you must talk to a lot of people who are looking to enter the field, and a lot of them coming from like a more traditional software engineering background. Do you have any advice that you would give people who are trying to enter this field today, a year from now, a couple of years from now? And if so, what would it be?
Yes, my advice would be that breaking into machine learning is possible, but it is also more difficult than you think it is. I have now worked with hundreds of students, I think I should go count. And those students who, a lot of the students that I work with are in university classes, they're going to college. And those students, I mean, they're working through an education, so they make steady progress. Other students of mine are less traditional. And I have seen so many people who want to start in this machine learning thing. They see AI, they see these LLMs, it's amazing, it's exciting, and they want to be a part of it. And it is a new way of thinking for them. It seems like it's easy, and it's not. Machine learning is a big field with lots of many subspecialties, many different kinds of models, many different kinds of techniques, and it takes time to master these techniques. But I have had non-traditional students who have succeeded. And the way that they have succeeded is by working steadily for a long time, for years in the end. I mean, along the way, they make incremental improvements. Maybe after 6 months or so, they might switch jobs to a job that's closer to machine learning, and then they get a little experience doing ML on the job. But mostly they're still a software engineer working with machine learning people, but they continue learning. They continue taking classes, building projects on the side, reading papers, discussing with other people, following blogs, just learning this large field. And 6 months later, then they get a job or an opportunity at work to do something that's actually ML, build a machine learning model for the first time because their manager has some idea for something and machine learning might actually work for this problem. So then they get one real world experience and then they keep working on it. And 6 months later, then they're ready to interview for a machine learning engineer position. So it takes dedication and time to to master this large field. It can be done, and it is hard. And that is my advice.
I think that's really good advice. And I like that you brought up that it's really dependent on the student themselves. Like they get what they put in. And the more that they try and the more that they become accustomed to this world, the more that they're going to succeed as they go through things over time. And I really like that. I think that's kind of the perfect advice for someone who is about to change careers. And it's something that I've observed in my career. My very first job out of college was
Yeah.
with Microsoft and it was a internship program for software development. And so just
Mhm.
going from that to a fully data science role took me somewhere. So I think that was around 2016 or 2017. It took me about 4 years to get into the field in like those incremental steps, like you mentioned. Like
Right.
first, it's just working as a developer on a team that does data adjacent work. And then next, it's actually working on a model on that team and then being able to use that to find a position within that company. And I think that it's really great. And like if students are at a program like Interview Kickstart or like your classes, they can get all the help that they need in refining some of those concepts and like in taking that step.
Yeah, I think you are a perfect example, perfect illustration of my point that it takes years to get closer and more into the machine learning world. On the other hand, you could go to school and learn how to do machine learning, but that's years too. It takes years to get a degree. And once you have the skills, people don't care if you have the degree or not. A degree can help open doors if people see a big name school on your resume or that you worked at a big company doing machine learning. That opens doors, and opening doors is important in the difficult hiring world we're in right now in machine learning and software engineering in general. But as long as you can get that door opened, then when you interview, all people care about is whether or not you have the skills. So if you have those skills, they will hire you.
Yeah, and I think that just like doing classes and like being a part of the program like forces you to kind of build some of those skills over the period over the better part of a year and can help you with that interview process. I totally agree. Like a title is just to open a door and just to get a recruiter interested. But what actually
Right.
matters is the practice and the work that you put in through your self learning or through your classes or through going to the Interview Kickstart program or going to the
Yeah.
classes that you teach and just iterating over time. And like what you get out is ultimately what you put in.
I agree.
I
That was
think
great.
that concludes all the questions. It was really nice to get to chat with you, and I hope we can work together more in the future.
Me too. Thank you for having me.
Thanks. Bye.
Bye. Okay. That was great. Thank you.
Yeah.